Your car would not start this morning. You turned the key and heard nothing. Or maybe a slow grinding crank that never fired. Your first thought was the same thought that costs most drivers between $150 and $300 they never needed to spend. I need a new battery. Stop. Before you drive to the parts store or call a mechanic, watch this first. A Japanese automotive engineer who manages fleet maintenance for over 40 commercial vehicles in Tokyo recently documented something that completely changed how his entire team handles battery failures. After tracking battery replacements across his fleet for 3 years, he discovered that a significant percentage of batteries replaced as dead were not dead at all. They were recoverable. They had been discarded and paid for again because the drivers and mechanics involved did not know the difference between a battery that has genuinely failed and a battery that has temporarily lost its charge and can be fully restored. The recovery process he documented costs almost nothing. It requires no specialist tools. It takes less than a day of elapsed time with minimal hands-on effort, and it works consistently on the exact type of battery fitted in Toyota, Honda, Nissan, and Mazda vehicles as original equipment. Today you are going to learn exactly how to determine whether your battery is genuinely dead or recoverable, and exactly what to do to bring it back to full working condition if it can be saved. Before anything else, you need to understand what actually happens inside a car battery when it fails, because this determines whether recovery is possible and what the recovery process needs to achieve. A standard 12-volt lead-acid battery, the type fitted in virtually every Japanese passenger vehicle, contains 6 cells. Each cell holds lead plates submerged in electrolyte, a mixture of sulfuric acid and distilled water. The chemical reaction between the lead plates and the electrolyte produces electrical current. This reaction is reversible, which is why batteries can be recharged. But 2 specific failure modes produce symptoms that look identical to complete battery failure while having completely different solutions. The first failure mode is sulfation. When a battery sits discharged for an extended period, or is regularly discharged more deeply than it was designed for, lead sulfate crystals form on the plate surfaces. These crystals reduce the plate area available for the chemical reaction, reducing the battery's capacity and its ability to deliver current. Mild to moderate sulfation is reversible with correct charging procedures. Severe sulfation, visible as large white crystalline deposits, is generally not recoverable. The second failure mode is genuine plate failure, physical damage to the lead plates from excessive heat, physical shock, or complete electrolyte loss. This is not recoverable. A battery with genuinely failed plates must be replaced. The diagnostic step determines which situation you are facing, and it must be done correctly before any recovery attempt. Locate your battery, typically a rectangular box with 2 terminals near the front of the engine bay on most Japanese vehicles, though some Honda and Nissan models position it further back or under a cover. Look at the terminals and the battery casing carefully before touching anything. White, blue, or green powder on the terminals is corrosion, a mixture of lead sulfate and oxidation products that forms where terminal connections allow air contact with battery acid vapors. Corrosion on terminals alone is not an indication of battery failure. It indicates a connection quality problem that is simple to resolve. Corrosion on the battery casing itself, particularly around the base or sides, indicates electrolyte leakage, which is a more serious condition. A cracked or swollen casing indicates physical damage that makes recovery unsafe. Do not attempt recovery on a physically damaged battery. Before removing terminals, spray a small amount of WD-40 on both terminal connections. This penetrates corrosion, displaces moisture, and makes terminal removal significantly easier without the risk of breaking a heavily corroded terminal by forcing it. Allow it to sit for 30 seconds before attempting removal. Always disconnect the negative terminal first, then the positive terminal. This prevents accidental short circuits during removal. Now test the battery voltage accurately. This reading determines everything that follows. A digital multimeter set to DC voltage, or a dedicated battery tester connected to the terminals with the battery at rest gives you the information you need. 12.6 volts or above indicates a fully or adequately charged battery. If your car is not starting with this reading, the problem is not the battery, it is likely a starter motor, alternator, or connection issue. 12.2 to 12.5 volts indicates a partially discharged battery. This battery can be fully recovered with correct charging. Below 12.2 volts indicates a significantly discharged battery. Recovery is possible but requires careful slow charging. Below 10 volts indicates deep discharge. Recovery becomes less certain below this threshold but remains worth attempting before replacement. 0 volts or no reading indicates either a completely open circuit, possibly a broken internal connection, or a short circuit condition. These batteries are generally not recoverable. If you have a bulb tester, connect it across the terminals. A bright light indicates significant remaining charge. A dim light indicates low charge but still present. No light with a battery showing voltage on the multimeter indicates high internal resistance, a characteristic of sulfated batteries that slow charging can address. If the battery shows any voltage above 0 and shows no physical damage, the recovery process is worth attempting before spending money on replacement. If what you are learning right now could save you the cost of an unnecessary battery replacement, subscribe immediately. Because the next section covers the complete recovery process that the Tokyo fleet engineer uses on Japanese vehicles, and the specific steps where most amateur attempts go wrong. The most important single factor in battery recovery that most drivers do not know is this: fast charging a deeply discharged battery does not recover it. It temporarily restores surface charge that disappears within hours. Genuine recovery from deep discharge or sulfation requires slow charging at low current over an extended period. This is why most drivers who attempt battery recovery at home report it did not work. They used a fast charger setting that appeared to work immediately, but produced no lasting result. The correct approach for a battery reading below 12.2 volts uses a charger set to the lowest available amperage, typically 2 amps or below on most consumer chargers. Connect the positive charger clip to the positive battery terminal first, then the negative clip to the negative terminal. Plug the charger into the wall socket. Allow charging to continue for a minimum of 12 hours at this low amperage. For batteries reading below 11 volts, extend charging to 16 to 24 hours. Low amperage slow charging allows the chemical reversal of sulfation to occur gradually at the plate surface, something that fast charging cannot achieve, because the high current simply forces surface charge without penetrating the sulfate crystal layer. The Toyota fleet engineer's data showed that batteries recovered using slow charging protocols maintained their recovered capacity significantly longer than batteries given fast charge recovery, because the slow process addresses the underlying sulfation rather than masking it. While the battery charges, address the terminal corrosion that almost certainly contributed to the apparent failure. Terminal corrosion creates resistance in the connection between the battery and the vehicle's electrical system. Even a battery at full charge can produce starting failure symptoms if terminal corrosion is severe enough to prevent adequate current flow. This is one of the most common reasons drivers replace batteries that were never actually failing. Use steel wool, not sandpaper, to clean the terminal surfaces. Steel wool removes corrosion without scratching the soft lead terminal material in ways that create new surface irregularities. Clean both the battery terminals and the cable clamp interiors until bare metal is visible. After cleaning, apply a thin coat of petroleum jelly, standard Vaseline, to both terminals before reconnecting. Petroleum jelly creates a moisture barrier that significantly slows future corrosion formation without affecting electrical conductivity. For batteries with removable cell caps, available on older Japanese vehicles and some current Nissan and Toyota commercial vehicle batteries, checking electrolyte level is an additional step the Toyota engineer performs as part of every battery recovery attempt. Remove the cell caps carefully using a flat screwdriver. The electrolyte level in each cell should cover the lead plates by approximately 10 to 15 millimeters. If any cell shows the plates exposed, the electrolyte has been lost through evaporation or leakage. Top up exposed cells with distilled water only, never tap water. Tap water contains minerals that contaminate the electrolyte chemistry and accelerate plate degradation. Distilled water is available at any pharmacy or grocery store for minimal cost. Do not overfill. Electrolyte that is too high will spill from the vent holes during charging and create corrosion on the battery casing and surrounding components. Fill only to the correct level mark visible inside each cell opening. After slow charging is complete, retest the battery voltage with the charger disconnected and the battery allowed to rest for at least 30 minutes. A successfully recovered battery will read 12.4 to 12.7 volts at rest and maintain that reading without significant drop over the following hours. The load test is the definitive confirmation of successful recovery. Start the vehicle and measure battery voltage during cranking. A healthy recovered battery maintains voltage above 9.6 volts under the load of cranking the starter motor. Voltage dropping below 9 volts during cranking indicates the battery cannot deliver adequate current, despite showing acceptable resting voltage, a sign that internal plate damage is too advanced for recovery to produce a reliable result. If the battery passes the load test, reinstall it correctly. Place it flat and stable in the battery tray. Reconnect the positive terminal first, then the negative terminal. Tighten both connections firmly. Apply petroleum jelly to both terminals after connection. Start the vehicle and confirm all electrical systems function normally. After reinstallation, run the vehicle for at least 30 minutes of highway speed driving to allow the alternator to bring the battery to full charge under normal operating conditions. Check voltage at the battery terminals with the engine running. A correctly functioning charging system should show 13.8 to 14.4 volts. Voltage outside this range indicates an alternator or charging system issue that will discharge even a fully recovered battery. Here is the financial reality that makes this process worth understanding for every Japanese car owner. A replacement battery for a Toyota Camry, Honda Accord, or Nissan Altima cost between $120 and $250 depending on specification and brand. The slow charging recovery process costs nothing beyond the electricity to run a 2-amp charger for 24 hours. Approximately 10 to 20 cents of electricity at standard rates. The terminal cleaning materials cost under $2. If the recovery is successful, which the Toyota engineer's data shows occurs in the majority of cases, where the battery shows no physical damage and reads above 0 volts, that is between $120 and $250 saved in under a minute of decision time. The batteries that cannot be recovered, those with physical plate damage, cracked casings, or 0-volt readings, represent genuine replacement situations. But the engineer's documentation shows these are a minority of apparent battery failures. The majority arrive presenting as dead batteries and leave as recovered batteries after a slow charge cycle and terminal cleaning that most drivers never thought to attempt. Your Japanese car's battery was engineered to deliver reliable service for 4 to 7 years under normal operating conditions. Premature replacement from recoverable discharge conditions is money spent on a problem that did not actually exist. The diagnostic and recovery process takes less than 5 minutes of hands-on time and 1 day of elapsed charging time. The replacement trip to the parts store takes longer and costs exponentially more. Know the difference before you spend the money. If this video saved you an unnecessary battery replacement, hit like right now and share it with every Japanese car owner you know. Subscribe for more insider knowledge that protects your car and your money. Comment below with your country and the next car topic you want covered. I read every single one. See you in the next video.